Hi, welcome to our next lesson. We will be dealing with trapezoids. The objective is how do we use properties of trapezoids to solve problems. So in order to understand how to deal with the trapezoids and problems dealing with it, we need to know what the definition of a trapezoid is. So basically it's a quadrilateral, that's means four-sided, with one pair of parallel sides. So as we can see in the diagram below, trapezoid A, B, C, D. Notice that the pink arrows are designated for parallel lines. So AB and DC are parallel. So it says below, the trapezoid has a base, has bases, so two bases, and two base angles. So label it below. So we have the sides, so let's do the sides. Those are the legs. So there's two legs for this trapezoid. And then we have the top base, and then we have the bottom base, and then we have the base angles. So if there's legs, then the base, and then the legs connect to the base will have their angles. So if the legs are congruent, then it is an isosceles trapezoid. So that's another type of trapezoid. You have the regular, whatever type of size trapezoid, and then the ones that are isosceles trapezoid. You've heard about isosceles triangle, where there's the two sides are congruent. Then in an isosceles trapezoid, those two sides are congruent. So in an isosceles trapezoid, the base angles are congruent, so that is A and B, and D and C. So D is congruent to C, and A is congruent to B. And the diagonals are also congruent. So that means AC is congruent to BD. Again, that's in an isosceles trapezoid. When we talk about the median of a trapezoid, you hear the word median, middle. So the middle of the trapezoid. So as you can see by the diagram, that line where it says median is at the center of the trapezoid. It's from the center of one of the legs to the center of the other leg of that trapezoid. So the definition is a segment whose endpoints are the midpoints of the legs. So you're starting at the midpoint, the middle of one leg, and going to the other midpoint of the other leg. So the theorem for median is the median of the trapezoid is parallel to the bases. So as we can see, yes, it's parallel. And let me make this, that's fine. So it's parallel. And in order to figure out what the median means in terms of the trapezoid, it is half the sum of the bases. So it's basically the average. So how do you find the average of something? You add up the number and divide it by how many you're adding up. So since there are two sides, two bases that you're adding up to get to the middle, so it would be the median is equal to half of base 1 plus base 2. And that's how you get the median. Basically, you're adding up those two bases and divide it in half to get the middle. Okay, so we're going to do an example based off the diagram above. So they said that QRST is an isosceles trapezoid with a median of XY. All right, so we have that, and we have the median. The median is in green, and we've got the two bases, QR and TS, in red and pink. So for the first one, they said find TS, so that's the pink one. If QR is 22, so I label it 22, and XY is 15. All right, so again, we're going back to that formula that's dealing with median. So that means the median XY is equal to half the sum of the top base and then the bottom base. So XY equals half QR plus TS. Now you just plug in the information that they gave you. They gave you XY, which is 15. They gave you QR, which is 22. And then you just solve for TS. And in order to get rid of that half, you notice that I multiplied 2, the reciprocal, and I did it to the other side. So what you do on one side, you do to the other side. So that way I can get rid of that fraction and then end up with a simplified form so I can easily solve for TS. So it would be 30 equals 22 plus TS, subtract 22 on both sides, and then I get TS to equal 8. So let me make this bigger. It's a bit light, but yeah, so it's TS is equal to 8. Now, they want us to find angle 1, 2, 3, and 4. So they gave us angle 1, which is 4a minus 10, and they gave us angle 3, which is 3a plus 32.5. Right. So what do we know about the angles? Just trying to make sure I got the right colors with this one. I'll use whatever color. So what do we know about the base angles? Based on the characteristics or the properties of it, we know that the base angles are congruent to each other. So that means this angle 1 and angle 2 are congruent to each other, and then angle 3 and angle 4 are congruent to each other. So we got 2 pairs of congruent base angles. All right, so since we know that information, then that means whatever we find for 1 will be the same as 2, and whatever we find for 3 will be the same as 4. All right. So before I even unveil this one, there's something else that you need to know. They only give us 1 and 3. So then how do we set up an equation to figure out what is x? Notice that we have this, they're both QR and TS are parallel. So if we go back to when we learned about parallel lines, and you have a transversal, so QT would be that transversal that cuts right through the parallel line. So when it cuts through the parallel line, it creates special angle pairs. So notice 1 and 3. They're both on the same side of the transversal, and they're inside the parallel lines. So the special angle pair that deals with that type of scenario is consecutive. So that means angle 1 and 3 are consecutive angles, and consecutive angles are supplementary. Supplementary means 180. So then I will put angle 1 and 3 together by adding them, and then equal it to 180. And I just combine like terms, solve, and then I end up with A equals 22.5. All right, we're not done yet because we still have to find angle 1, 2, 3, and 4. So let me just expand this. So for angle 1, I just plug in whatever I found for A, and then I found it to be 80. So then if angle 1 is congruent to angle 2, then angle 2 is also 80. And then for angle 3, I just plugged in my 22.5 wherever there was an A, solve it, and then I got angle 3 as 100 degrees, and if angle 3 is congruent to angle 4, then it is also 100 degrees. So I found T and S, 3 and 4 as 100, and then angle Q and R, which is 1 and 2, as 80. Again, you're using everything you know about an isosceles trapezoid and then applying it in order to solve for any missing angles or sides. All right. So you have learned all the different types of parallelograms, I should say quadrilaterals, in this unit. So we have a Venn diagram. Most of you have seen Venn diagrams. And quadrilateral is the universe. So quadrilateral deals with four-sided shapes. Now, in order to categorize them, we have two groups. We have the parallelograms, And then we have the trapezoids. And notice that trapezoid is all by itself, but if you were to break it down for another subgroup, then you will have the isosceles trapezoid. But again, it's still part of the trapezoid family. So in the quadrilateral world, we have parallelograms. And what are the three different types of parallelograms that we learned? We learned about the rectangles, and we also learned about rhombi. And those two have the same characteristics as a parallelogram. Basically, a parallelogram, you have two pairs of congruent sides, two pairs of parallel sides. And then their diagonal, they also have their diagonals that are congruent to each other. Not congruent, they bisect each other. So with a rectangle carries some of the characteristics of a parallelogram, and a rhombi also does the same. And there was something in the previous lesson where it says rectangle plus rhombi equals a square, because the square has all the properties that a rectangle has, all the properties that a rhombi has, and all the properties that a parallelogram has, and all the properties that you would see in the quadrilateral family. So this is a way to categorize the different shapes into their correct groups. And like I said, trapezoid is in its own world. It is in the quadrilateral universe, but it doesn't have the same characteristics as you would find a parallelogram, rectangle, square, and rhombi. Right. So we have reached the end of this, and just to recap, we learned about a trapezoid. It's a quadrilateral with one pair of parallel sides. It is composed of two bases, two legs, and two base angles. And if you have the legs that are congruent in a trapezoid, then it's an isosceles trapezoid. And in an isosceles trapezoid, the base angles are congruent and the diagonals are congruent. And the median of a trapezoid is a segment whose endpoints are at the midpoint of the legs. And the median is parallel to the bases. And it's also half the sum of the bases. So if you were to put it into equation form, the median is half the sum of base 1 and base 2. And we learned about the quadrilateral family or quadrilateral universe, where it involves two subgroups, parallelogram and trapezoid. And under the subgroup of parallelograms is rectangles, rhombi, and both combined, square. Right. So we've reached the end of this lesson, and I'll see you around.